U.S. combat drone XQ-58A Valkyrie flaws, say Chinese engineers. Their analysis suggests its design prioritized weapons and fuel at the expense of maneuverability. Previous study had warned the drones could quickly form large swarms and pose a severe threat to the PLA in a conflict. Chinese aviation engineers say they have worked out some critical performance constraints of a stealth combat drone, still under development in the United States. Their estimates are based on some photos, openly available information and reverse engineering software. They found that the XQ-58A Valkyrie, an unmanned combat aerial vehicle, was not good at aerial combat. When making a U-turn, for instance, it can withstand a pull of only about 1.7 times that of gravity, according to their calculations. In a dogfight, most fighter jets need to brake against a force 7 times that of gravity or higher. This is a weakness, but the unusual design also signals a major break with tradition in the U.S. military, suggesting gains in other areas, the researchers said. Through the inversion of the XQ-58A design process, it can be seen that with the continuous breakthroughs in artificial intelligence and network data transmission technology, the loyal wingman, represented by XQ-58A, will gradually become the main force on the battlefield and become a new leading power in the transformation of the man-machine coordinated combat model, senior engineer Liu Yuanjia and colleagues at the Shenyang Aircraft Design and Research Institute wrote in a paper published in domestic peer-reviewed journal Aircraft Design. The U.S. Air Force last month awarded a $13.2 million contract to defense contractor Kratos to get the XQ-58A ready for service by 2023. The company said in May that it would deliver the first production unit this year. Since its debut in 2019, the drone has made 6 test flights and suffered 2 mishaps in landing and takeoff, with a relatively low cost of $2 million. It is expected to be produced and deployed on a large scale. The XQ-58A is a backbone component in the U.S. Air Force's Skyborg program, which aims to provide AI wingmen to F-22 and F-35 stealth jet pilots for combat or surveillance missions. Other defense contractors, including Boeing, have come up with similar products. China was worried about these drones because they would add further uncertainties in the event of a war. A Chinese military study earlier this year warned that the U.S. could station a large number of XQ-58A drones on small islands or ships east of Taiwan. With a rocket-assisted takeoff system, these drones could quickly form large swarms and pose a severe threat to People's Liberation Army forces crossing the strait should a conflict break out. They could even attack some targets on the Chinese mainland with the help of stealth technology, or clear a path for the F-22 or F-35 squadrons. Although the XQ-58A will still be in the testing and verification stage in the short term, the accumulation of related technologies and the verification of application models will affect the basic style of future air combat, and we should pay full attention to this, said Professor Guo Zheng and colleagues at the National University of Defense Technology in a paper published in National Defense Technology in February. Liu's team said that the main purpose of their study was not to replicate an XQ-58A but to find the U.S. military's hidden motivation from cold data. They found that the U.S. designers tried to pack as much equipment and fuel into the drone as possible while keeping its wings, engine and total size as small as possible. These design priorities may suggest that the U.S. military put weapons, surveillance capability, and range before maneuverability. The XQ-58A was advertised as a reusable drone, but was actually designed and built to be expandable, to carry out suicide missions, according to Liu. This would allow manned aircraft to command outside the defense zone, and drones to go deep into the hinterland to complete high-risk attack missions, he said. The Chinese military has several methods to counter the XQ-58A and similar aircraft, according to Guo's study. China has built numerous low-frequency radar stations while developing and testing new technology such as quantum radar to detect stealth aircraft. Under the premise of effective detection, the XQ-58A's weaker maneuverability can lead to its destruction by ground-based mid-range anti-air guns, air-based over-the-horizon missiles, or close combat by fighter jets, Guo and colleagues said. Electronic warfare devices could cut off the communication between the drone and human command, or bring down a swarm of drones with one powerful shot. From a powerful electromagnetic pulse weapon. Using drones against drones can also be an effective tactic, according to Guo. The defending party can use the unmanned wingmen to feint and maneuver to force the enemy's manned aircraft to take actions such as radar startup and evasion, they said in the paper. China is developing hypersonic drones that can fly at 5 times the speed of sound or faster. One recent study by Chinese Air Force researchers suggested that a hypersonic drone could quickly catch up with an F-22 and fire a missile or cannon from behind. The XQ-58A's top speed is Mach 0.95, according to the U.S. Air Force.